Geotrig, this is day 3 of logs. Today we're going to start off with log inverses. There are 2 of them that we're going to apply. We've kind of halfway done this already, just didn't tell you yet. That first one, which is a base that has an exponent as a log of the same base of x, is equal to x. This actually is kind of how we were able to cancel the logs. When you guys had a log of something, log base something equals the same log of the same base, right? I just kind of said, hey, if we have 2 logs that are set equal to each other, the bases are the same, that means our numbers inside them would have to be the same. And if that's the case, you can just cancel the logs. But what's really happening, there's a big word for that, it's called exponentiate both sides. Basically create them as those logs as exponents, which then leads to this point of the logs canceling, leaving you with the number that is inside of the log. Okay? So, if the log's base and the base that is the base of the exponent are the same, they'll all disappear. It all cancels, and you just get x. On the flip side, what happens if the exponent is inside of the log? So you got log base b of that same base to an exponent x. Those will also cancel each other, leaving you with x, which is the exponent. Okay? So, let's try simplifying 42 to the power of log base 42 of 5. You're hoping you see these and you're saying, yes, I can do these. I can make this work. Some of it is going to take a little bit of changing things around so we get those same bases. This is exactly kind of like the very, very first day where we tried to get our bases the same so that our exponents had to be the same. We just didn't have to deal with logs. There's a way to avoid using logs at that point. But pretty soon we're not going to be able to avoid that. So the first one there, what do we think is going to happen here with this? Bring someone in the room and you guys really don't talk anymore. Some of you guys didn't even notice you walked in. Yes? Yes, the 42 and the log base 42 will cancel. So what I like to do is I like to just cancel them out. And then the answer is 5. Done. Walking away. The next one is 9 to the power of log base 3 of 5. Uh-oh. 9 and 3 are not the same, are they?
3 times 3.
Okay, 3 times 3 is 9. But what does 3 times 3 really mean? Or what's another way to write that?
3 squared.
3 squared. Ooh, I like this. So could I do 3 squared to the power of log base 3 of 5? What is going on there? What's that called? This is one of our exponent rules. What's that one called? Thank you. What is this called? What is this rule called? Power of a power. And what do you do with power of a power? You multiply the exponents. So therefore, this one should be 3 to the 2 times log base 3 of 5. Now wait a minute. Ooh. First of all, I can only apply that inverse rule up above, that first one here, if the base and the log are basically next to each other, right? Directly. I got a 2 that separates us. What can I do with the 2 that's out front of a log? Where? Moving not out front. It's already out front. To the top. Remember that 2, guys, is 2 times a log. And rule number 3 from the other day says that I can move this 2 as an exponent. So would you guys be okay with me moving that to an exponent position to get 5 squared? Or we could say what? 5 squared is 25. But now, 3 to the log base 3 power will cancel, leaving us with 5 squared or 25. Done. So far, all of them are dealing with the first one. I'm guessing the next slide will deal with the next inverse. So can we apply that exact same logic to 10 to the power of 4 times log base 10 of the square root of 3?
Yeah, so wouldn't it be square root of 3 to the 4th power?
Okay, so this would be 10 log base 10 of square root of 3 to the 4th power. They cancel, leaving you with square root of 3 to the 4th power, which I think we should fix. We should fix that. Square root of 3 to the 4th power. That doesn't seem. I think we can simplify that.
Wait, would it be
3 squared. How did you get 3 squared? You're right.
Well, because like the square root can cancel with like a square. So I don't know.
You're on the right track. The square root is the same as what power?
Square.
1/2. So therefore, it's 3 to the 1/2 to the 4th power. Power over power again, you multiply. So it's 3 squared, well, not 2 squared. 3 squared, which is 9. Done. So the reason why we're doing these inverses, because eventually we will be taking logs of both sides. And you're going to need to know how, either by taking a log or raising a log as an exponent, how you can use that to your advantage to cancel out logs to get rid of them. The whole purpose, guys, is to get rid of logs where you can. Use change of base where you have to. So, next group. The next group is... Let's start with the far right. Actually, let's start in the middle. We'll come back to the first one. Because that one's an interesting problem. You got to use your exponent rules on that one. But let's take a look at the center one. Log base e of e to the 14. What's going to happen with the log base e of e? They cancel each other. So they're gone. Your answer is 14. The last one, 25. Wait a minute, can that be of base 5?
no?
Yes.
Yeah.
25 is 5 to the
Second.
2nd power. And what happens? They cancel, leaving you with 2. So hopefully you're pretty happy about all of this. But now we've got to go back to that first one. Kind of goes back to this. Those last 2 examples, that was the second inverse. Now we're going back to the first inverse property. 3 to the log base 3 of 4 plus log base 3 of 5. I think there's a couple ways we can handle this. Let's do 2 different ways. There's an efficient way, then there's a slightly inefficient way.
Do the efficient one.
Let's do the efficient way. Tell me what it is then. What do you recognize? Here's the problem. I cannot apply that inverse rule with just the first log and the 3.
Yeah, you can't because the other one has to be the same.
Because the other thing has to be the same, right? You have to have one log. So what do you mean multiplying them? Because you're adding. You add logs at the same base. What do you do with your numbers then in a single log? Multiply. So would you guys agree that this is 3 to the log base 3 of 4 times 5?
Yeah.
And now they cancel, leaving you with 20. That's probably the most efficient way to get that problem done. There's another way to do this using our exponent rules. When do we add exponents? What are we doing with our bases? Multiplying. So would you guys agree that this would be 3 to the log base 3 of 4 times 3 to the log base 3 of 5? Because those bases are the same, I would take their exponents and add them. But now they're individualized, right? Gone. What does that equal? 4 times gone. 5 equals 20. Two different ways to do the exact same problem. Awesomeness. We didn't officially talk about this, but it's a good time because it's fairly easy. Again, we talked about this already because we had to do the change of base. Our calculators only have two bases readily available to us. It's log base 10 and log base e. And so they say, hey, we have something called the common log, and the common log is the log base 10. And since we use this so often, so common, mathematicians start to get lazy. And so they start writing it as log x and not log base 10 of x. So if you see a log and there is no base, and you guys should have seen that in a couple of your problems already, but it didn't matter at that time, it's really log base 10. So you need to kind of get 10s there. If you can get a 10 in the x spot, then you can cancel a log. Or if you can raise it on the base 10, you'd cancel it. And the other one, the naturally occurring number in the world, is e, just like pi. And so they say the natural log, ln x, instead of writing out log base e of x. ln x. And we did both of those when we did change of base. Because those were on my calculator. They're on your calculator. They're on everybody's calculator that's scientific. Okay? Any questions on that? Just for common knowledge that allows us now to have the ability to solve every equation now. We're going to go solving. So, here we go. Make sure your shoes are tied, because this stuff will knock your socks off. Okay. What we're going to do, guys, is that you see that we're just having exponential equations. We now, instead of having x's or a variable on the single line, basically by adding, subtracting, multiplying, dividing, it's now as an exponent. And our job is to solve for that, what value of x or y or z or whatever it is that would make that statement true. And just like I have in parentheses, and I actually stole that from Mr. Havlicek, you hit it with a log. Because what you do to one side of an equation, you have to do to the other. Basically, when I say hit it with a log, it's take a log of both sides. Now, this is what you need to do. You need to take the log with the base that's the same as your exponent. What's the exponent on this whole problem?
2.
Or what's the power?
2x.
So the whole thing is 10 to the 2x, right?
Yeah.
What's the base?
10.
It's 10. What log base am I going to take of both sides? Log base 10. So here we go. Let's write this out. I'm going to write log base 10 of 10 to the 2x equals log base 10 of 52. Did I have to write little log base 10? Or could I just wrote log? I could have just written log because that's the common log. Hey, do you guys recognize that that's exactly setting up what we just did? What's going to happen with the log base 10 of 10s? They're going to cancel. So you get 2x equals log base 10 of 52. To officially get x by itself, you will do what? Divide both sides by 2. Here's the concern that I am going to have. I took out the little 10 because I really don't need it. That, guys, is the exact answer. So if I say, give me the exact answer, you don't even need a calculator, you're done. If I ask for an approximation, I'm going to have to use my calculator. Sometimes I have to use change of base. But here's a really cool thing. Do I need the change of base? Do I have the log button on my calculator? Yes. Also, this does not become log of 26 because this is a log. This one's not in a log. You cannot put those together. I can't stress that enough. It's log of 52. I'm doing something, and then I am dividing it by 2. So take your calculators out. Take log of 52 divided by 2. What do you get? So log of 52 divided by 2 is, say it again, 0.858. And here's the cool thing. I have a potential answer. Can I put it up here? What's 10 to the power of 2 times 0.858? It should be really super close to 52. Is it going to be exact? No, because we made an approximation. And so be careful on that. You're not going to be perfect on it, but you'll be pretty darn close. Okay? Any questions? Also, because of the next problem, it's 3 times the exponent, right? That power thing. You need to isolate it first before you hit it with a log. And make your life a lot easier, okay? So what's really the first thing I should do in that second problem? Divide by 3. Unfortunately, is 350 divisible by 3 nicely? No. Is that going to be really that big of a problem? No. No, it's not. Okay? So, yeah, so what? I have this fraction. So be it. But I want to get rid of that 2. What am I going to do to both sides? Hit it with a log. What base?
10.
Not 10. Technically I could, but I don't want to. I want to use 2. I'm going to take log base 2 of both sides. So, log base 2 of 2 to the x plus 4 equals log base 2 of 350 over 3. What happens with log base 2 of 2? Cancel. Are you seeing those inverse operation things going on? Leaving me with x plus 4 equals log base 2 of 350 over 3. That's getting close. The last thing I would need to do is subtract 4. Subtract 4, subtract 4. Can I put that subtract 4 together with that 350 over 3? No. One of them is in the log, the other one is not. So they have to be separated. Stay separated. So x is equal to log base 2 of 350 over 3 minus 4. No. That's the exact answer, right? If I didn't let you guys use calculators on the test, that's as far as you go. But if I asked for the approximation, how can I change this? We can't put log base 2 on our calculators. At least most of us can't. How am I changing this, guys? Use what we did Thursday. Use the change of base. If I use change of base, x equals, what's the log base 2 of 350 over 3 going to look like? You have two options. Do you want to use log or natural log? Tyler?
Would it be wrong if you, like, when you divide it by 350 by 3, would that be wrong if you had a decimal?
The reason I'm not using a decimal is because it's going to end up in some kind of thirds, right? So you're going to end up with 0.333333 or 0.6666666666, and that's just not. It's in itself is a non-terminating decimal, so leave it as an improper fraction. I'll make the choice for you because no one's speaking up. I want natural log. I think it's easier to say natural log. Natural log of our number, which happens to be 350 over 3, divided by natural log of 2, and I'll subtract 4. It's hard to see because the break in the board there. That's a minus 4. So if you take your calculator out, what do you get? Now, I highly suggest you do this in pieces. Take the natural log of 350 divided by 3 first, hit enter. Write that down, take natural log of 2 and divide those together. Then take 4 from it. What do we get? I'll pause the video so we don't have a 20-minute wait. 7 of us, or several of this, say 2.86. Okay. Did we check it up here, though? So that would be 2 to the power of 6.86. Multiply it by 3. Does it give us 350?
Multiply by 2.
Why multiply by 2? We need 3. It's a 3 out front.
What?
That'd be a 3 up there, Bob.
2 to the 2.86 plus 4, but that'd be 6.86, right? So 2 to the 2 to the 6.86. Put that on your calculator.
I don't have my calculator.
Well, you should.
Well, I know. 48.
And then multiply it by 3. It comes out really close, right?
Yeah.
Not going to be perfect. Be rounded. So I'm going to stop here. I'm going to say do the very last worksheet. Tomorrow we will cover what happens when the bases are, there's 2 different bases, which means we will have to mess with our logs just a little bit more, which would be actually for page 6. Have a great day.